Hello, let's continue our Sudoku adventure with Changing Teams by Strosahl. And I have an announcement to make. There is now a tracking spreadsheet that we've put a lot of work into, both myself and others in the Sudoku adventure setters. We have put together this tracking sheet. It is a pretty magical spreadsheet. I will go over at the end of the video how to use it. And I'm going to be talking about both YouTube and TikTok and how you might be able to utilize the tracking sheet. But the idea is that it automatically updates and you will be able to go through all the old adventure puzzles as well as discover the new ones right as they come out. As a result, my videos are here still as walkthroughs. And if you want to support and give feedback on the puzzles, the YouTube videos are still a great place to do that. But it means you don't have to open the video for 2 seconds just to go to the description and open the puzzle. And I think that's going to be better for the algorithm as well, because the algorithm does not like when someone opens the video and then immediately closes it. So do definitely utilize that tracking sheet if you'd like to solve the puzzle through that. And if you're interested in watching the video and interested in watching it and giving feedback, we would all very much still appreciate that. And so then do so afterwards. Or if you're just the kind of person who watches and doesn't solve, that's perfectly fine as well. Nothing will change for you. So cool. Let's go over the rules to this puzzle. It is called Changing Teams. It's by Strosahl. So we have normal 6x6 Sudoku rules, and we also have standard arrows and clones. So if that's enough for you, go ahead and start solving. But I'm going to go over the rules. So in 6x6 Sudoku rules, in every row, every column, and every 2x3 box, that we are placing the digits 1 to 6 exactly once each. We also have arrows in the grid. That's these arrows with a circle connected. The digits on the arrow sum to the value in the circle. So if this was, say, 2, 3, 2 plus 3 is 5, so we put a 5 in the circle. So that is arrows. We also have clones. So we have these little outlined cells with letters on them. Cells with the same letter have the same value. So if I were to put a 2 here, then every other cell that's labeled A is also a 2. If I put a 1 here, every other cell that's labeled B also is a 1. All right, and that's it. Those are the rules. There is a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, how should we get started? There's an interesting relationship between all of these clones, and that might be where to start. So we know we can add A and C to get this value. We can also add C and D to get this value. B and D get this value. A and B get this value. So let's think about this a little bit globally, which might be helpful. So what's the minimum sum of 4 different digits? A, B, C, D are 4 different digits. We know that A is not the same as B or C. We also know that A is, do we know that A is different than D? We don't actually know that A is different than D, do we? Because it could go here and here. Ooh, so it doesn't have to be 4 different digits. I thought it had to be. How about A, B? So A and C and A and B are different. How about B and C? B and C do not have to be different. Okay, so we got to be a little bit careful here, because that doesn't mean that they're different digits from each other. All right, so scratch that. What else can we say about this? C is involved in 2 different sums here. So is A, so is D, so is B. They're all involved in 2 different sums. I mean, we know none of them are 6. Does that help? So none of these are 6. We can't put a 6 on any of these. None of them are 5 either, right? So say A was 5, right? I could add 5 to 1 to get 6. But then this 5 would have to add... Oh, I guess that would just mean that B is also 1. This would be 6. B would be 1. You know what? That actually works. I was thinking that wouldn't work. But it is possible. So I guess they can be 5, huh? We know they can't be 6 because you have to add something to 6 to get something bigger than 6, and we can't put something bigger than 6 into the sum. All right. I'm clearly not seeing what we're supposed to be seeing. I'm seeing interesting stuff that doesn't pan out. Maybe we think about it this way. So let's give a color to A, green. So whatever the green digit is goes here or here. I'm seeing if this is helpful before I really expand on it more. A could be D though. Yeah, see, that's the issue. We can't place it. C and C look into here. So one of these two is C. So I guess the question to ask is, can C be the sum of two different digits? Basically, could it be at least 3? I don't see why not. Okay. We have B and B also going here. Okay, let's start with this. This is more typical arrow stuff. These are 4 different digits. I guess first of all, what we know is none of them are 6, right? We can't put a 6 on an arrow like this because then what would we add to 6 to get bigger than 6? It doesn't make sense. So none of these are 6. So the 6 is in one of these 2 cells. That's going to point in here. These can't be 6 because of the arrows. So that places the 6 here. That 6 is going to look down. These can't be 6, putting a 6 in one of these 2 cells. Those look up. This 6 looks down. This can't be 6. That places this 6. 6 looks in here. This can't be 6. So 6 is in one of these 2 cells. Okay. Can I do more than that? I'm not sure. So we know A plus C is 6. That's interesting. All right, let's do what I was going to do here. So these are 4 different digits. The minimum 4 digits can add to is 10. 1 plus 2 plus 3 plus 4, as long as they have to all be different. These do have to all be different because they're all in the same box. The minimum sum is 10. Now we know that this sum, the sum of these 2 cells, is equal to the sum of these 4 cells. So that means that these sum to at least 10. So these need to be 2 digits that add to at least 10, and this cell can't be 6 because we have this 6 here. So the max these can add to is 11, right? So these could be a 5-6 pair, or a 5 here and a 6 here. That's one possibility to add to 11 if we wanted to. If we wanted to add, that's the only way we'd add to 11. If we add to 10, we could be a 6 here with a 4 here, or we could be 5 plus 5. So these are the only options for these 2 cells. Now, these are both 6, so we know these add to 12, so we can actually figure out this digit. Watch this. What does an entire box add to? Well, we know the box has 1 through 6 exactly once each, and if we add 6, the triangle number for 6, right, 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21. And so we know the entire sum is 21. We know that these add to 12, 6 plus 6, and we have another 6, that's 18. So how do we get from 18 to 21? Well, we need 3 more. So this cell needs to be 3 to make the total sum of the box 21. Another way that we could have done that is you cannot put a 3 on this arrow because in order to add to 6, you need another 3. And so since these arrows can't have 3s on them, the 3 ends up here. Okay. Now, that does mean there's a 3 down here somewhere. I don't know if that's important. If we wanted this to be 6, we couldn't put the 3 here. So D would end up 3. Seems reasonable. We know that neither A nor C is 3. Yeah, because these are 1, 5, or 2, 4. So are these. All right, can we do more with combining sums? That's what I'm kind of looking for here. I haven't really utilized the clones much, have I? D can't be 3. This D can't be 3 because there's a 3 in the column, which means this D can't be 3, which means there is a 3 on this arrow, which means it cannot add to 6. It has to be 2 plus 3 adding to 5, and that puts the 6 here. So if this is 5, this cannot be 4 because we know these add to at least 10. In fact, we know this is a 1-4 pair, so it does add to 5. Either way. And so that means B and D are both from 1-4. And we know that B and D are different digits. So it's 1-4 pair. I guess it's same for the row anyway. Okay. Can we say that A plus C? Okay, we know the total sum of this. We know the sum of A plus B plus C plus D. We know these add to 6 and these add to 5. So the total sum is 11. So these add to 11. So that means these add to 11, which means they're a 5-6 pair. This can't be the 5, or 6. So this is the 5, and that's the 6. Right, if this adds to 6, we're either doing 1 plus 5, which we can't do, or 4 plus 2, which hopefully we can do. So we know that B is 4, and we know that A is 2. That means D is 1. 1 plus 4 is 5, and C ends up 4. So these did end up different. Oh, no, these didn't end up different. B and C ended up the same digit. Okay, so I'm glad I realized that. This 2 makes this a 3 and a 2. Okay. That was really good progress there. This is the 1 plus 5, so that's 5 and 1. I guess I'm just finishing the rows, 5 and 1 as well. But luckily they do add to 6. So far our math is okay. This is 2 for the column. What are our options here? So we could add 1 to 2 to get 3. This can't be 2. If we added 3, it would be 5. We can't do that. It can't be 4, 5, or 6. So it does have to be 1 plus 3. And our final digit's a 4. These 2 digits are, we need a 2, which goes here because of that 2. And then this is a 5. These 2 digits are 3 and something. What did I miss? 3 and 6. Okay. This digit is known. It is a 1. So we can probably repeat this trick, but actually this 2 looking down tells us this is 2, and 1 plus 2 is 3. And that makes this a 4 as well. And so now the 2 digits needed for this column, we need a 3 and a 5. This 5 tells us the order. That resolves the 6 and the 3. We now have a 1 and a 6, and we're done. Really neat puzzle, Strosahl. Thank you for that one. Yeah, that was cool. Had to think about the right things. But yeah, combining these arrows here was definitely helpful as far as I could tell. Yeah, just some intricate things to spot here, which was really neat. A really nice use of arrows and clones. Not too heavy-handed with the clones, which was neat. So yeah, let me know how you did on this one. And now I'm going to go over how the tracking spreadsheet works. So if you're on YouTube, it's always going to be in the description. There'll just be a link you can click to find the tracking sheet, as well as I'll also still include the link to solve the puzzle directly, of course. If you're on TikTok, I have a link tree that's in my bio. And so you can click on the link tree, and in the link tree, there will then be a link to the tracking sheet. I recommend opening it in an external browser and not within the TikTok browser, but it's up to you. I think everything should work through the TikTok browser, but I'm not sure.